have a look into these videos. What is the important steps that they are following, and you have to do the model, RCC model.
The structural model. In applied the brick wall loads or blockwork loads on the beams. In this lecture, we will learn how to assign staircase loads to the.
I think you are not getting the voice. Are you getting the voice?
Yes, sir.
Yes, sir.
Not my voice, the video voice.
The structural model.
Yes, sir. Video voice.
See, in our
Yes, sir.
model
We are getting.
or in our architectural drawing,
Okay, then I
we
am
have
not
two
getting.
staircases. One is in this area and another is in this area. In our model, we have stimulated the staircase as cutouts, but the loading will come on the structure. How to stimulate this structural loading on our structural model? What we usually do is that we assign the uniformly distributed load on the floor beams and mid landing beam. As per the orientation of this structure, or as per the orientation of this staircase, we can see here that this is a mid landing level and this is the floor level. Because staircase, if we are going up from here, so at this point it will be a mid landing and at this point it will be a floor level. So if we start from here, we have to model a mid landing beam here. This is a grid elevation along grid B and elevation along grid 3 and 4. So what we need to do here is that we need to go to elevation and B, apply and close. So we also need to check here that in draw snap options we have line ends and midpoints as checked. So we need click on apply and close. Go to draw, floor and wall objects, draw beam column brace and draw beam column brace. We can select the beam size of beam 400 and 750 and we need to draw beam like this. So as all stories optional selected, so it had drawn beams on all the floors, which is the incorrect way. So we need to select one story here and draw beams like this. And then we will go to edit and delete. So now we have deleted all the floor beams, but now we have only mid landing beams. Now we need to apply the staircase load on this mid landing beam. So I have prepared this rough calculation. Our span of the staircase is 4.91 meter. So we will enter the width as 4.9 meter. This length is approximately 7 meter. Same is the case for this one. So we will enter the value as 7 meter. And this value is approximately coming to be 30 and 15 kilonewton per meter. So 30 kilonewton per meter will be UDL on the mid landing beam and floor beams, and 15 kilonewton per meter will be UDL for live load. So first of all, we will apply SIDL loading for staircase, that is superimposed dead load. We will select all these floor beams, all these mid landing beams. we will go to assign frame loads distributed, select SIDL here, and the value is 30, and then we will left click on apply. So now we have applied SIDL on mid landing beam for staircase. Now we will go to any floor plan. We will go to display undeformed shape. Actually what happens is that whenever this loading is visible, we cannot select one story and all story. So we need to go to display undeformed shape to let the option come. Here we will select the all stories option, and then now we need to apply superimposed dead loading on this side also for staircase. So what we need to do here is that we cannot apply uniformly distributed load on the shell object. So what we need to do is that we need to do simple WL by 2. That is, we need to calculate point load on this point and this point. So we can multiply 30 into 4.91. That is approximately 30 into 4.91 divided by 2. That is WL by 2. It comes to be around 75 kilonewton point load on one side. So what we can do is that we can go for all stories, all joints, this joint and this joint. Total 58 joints are selected. We can go to assign joint load force, and this value can be minus 74, because this value is approximately 73.65. so we can take 74 kilonewton load value, and then left click on apply. Now we need to check the direction of the loading that we have just applied. Display load assign joint, SIDL, and apply. So the the direction of the joint load is correct. That is in the direction of gravity. Now we can go to display undeformed shape. Now the staircase loading for SIDL load case is complete for this area. Similarly, we have to calculate the loading for this area also. Before that, we need to understand whether we need to model mid landing beams or not. Here in this area, you will see that mid landing beam will not be required, as
Sir, audio is not audible. Sir, sir,
Sir,
అన్నిటికీ అసలు యాడ్ కాన్ఫిగర్ చేద్దాం నేను ఒకసారి ఇచ్చాను.
this lecture we will understand what are the live load reduction factors, why and how they should be applied in the ETAP software. Basically what happens is that practically all the floors are not loaded on their full capacity at one time. So what code allows is that the code allows us to reduce the live load in designing columns, load bearing walls, piers, their supports and foundations. So as per this IS 875 part 2 for floor supporting structural members, the reduction in assumed total imposed loads, which in our case is 4 kN per meter square for all the floors and 1.5 for terrace, we can reduce these loadings as per the number of floors to be carried by the member under consideration. So in simple words, if the number of floors are above 10, we can reduce the 50% of the imposed loading. So in our case, the number of floors are above 10, so we can reduce the loading by 50%, and if the number of floors are between these values, the loading may be reduced by these factors. This this practice is followed by American code also, and this practice is followed by Indian code also. On the last of IS 875 there is one example. So here you can see that this is a practical example of how we should reduce the floors. So here you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So after 10 floors, for design of this column, he has taken off 1 minus 0.5. That is, he has reduced the loading by 50%. And for between 9 and 8, 7, 6, 5, 4, up to 4 floors, he has taken 40%. And if the number of floors above is only 1, no reduction. If the number of floors above are 2, then 10%, are 3, 20%, and are 4, 30%, and more than that number, it is approximately, it goes up to 40%, and then if the number of floors above are more than 10, then the reduction is of 50%. So if we are right now talking about the bottommost column here, for the calculation or for the live load reduction, the value has to be reduced by 50%. And how that reduction has to be applied, we need to go to design, live load reduction factors. We need to select Indian IS 875 1987, and we need to check on use default minimum factors, that is 0.5 and multiple stories 0.4. We need to select columns only, that is the reduction has to be applied on columns and not for all forces or components, only to axial load, not to this shear force and bending moment. Only reduction in axial load is allowed. So we left click on OK to assign the live load reduction factors. This is somewhat a complicated or confusing part in the beginning, but you will eventually get what exactly are we trying to accomplish here.
This video will be important for you. Response spectrum load cases.
Until now we
Please
have
follow this.
Completed the step 10. In the next step we will define the load cases. Now what exactly are the load cases? In ETABS we need to define load patterns also, as well as load cases also. We have already defined the load patterns, and all these load patterns has already been copied to the load cases. So what we can do is that we can go to define and load cases. We will notice that all the load patterns are copied here. After that, for the response spectrum design, we need to left click on add new case. We need to name it as RSX, load case type as response spectrum. You will notice that the mass source has already been added here. After that we need to left click on add. So here you will see that acceleration, the load name is U1, function has to be IS1893. Most of the people, what they do is they left it as blank, default uniform. It should not be like that. It should be as per your defined response spectrum function that we are defined in the beginning. After that, this scale factor. The scale factor is also very confused in the beginning by the engineers which are learning ETAP software. For Indian codes, it has to be I into G by 2R. That is, I is 1.2 for our building importance factor into G 9.81 divided by 2 divided by R, that is response reduction factor for our building, which is 5. So it has to be entered initially as 1.178. And model load case has to be model. Model combination method is CQC, and direction combination type, that is sum of root of sum of square. Model damping has to be 0.05%. So we need to left click on OK. After that, we need to enter RSY into G 9.81 divided by 2 divided by R, that is response reduction factor for our building, which is 5. So it has to be entered initially as 1.178. And model load case has to be model. Model combination method is CQC, and direction combination type, that is sum of root of sum of square. Model damping has to be 0.05%. So we need to left click on OK. After that, we need to enter RSY. That is also a response spectrum function. And we need to enter direction as U2, function as IS1893, and scale factor is same 1.172. And after that, all these things are same. We have defined RSY acceleration U2 as 1893 1.172. That we had calculated, that is I into G by divided by 2 into R. So left click on OK option. After that, we need to define the vertical response spectrum also, that is RSZ. We define it as response spectrum. Left click on add acceleration and U3. Function is IS1893, and this has to be multiplied by 2 upon 3. That is, our scale factor is 1.172 into 2 divided by 3. So it has to be entered as 0.7848. So left click on OK option. So now we have defined response spectrum function in all the 3 axes, that is RSX, RSY, RSZ, and with the scale factor of I into G by 2R. This is the home page of ETAP software. See, it is a CSI knowledge base that is available for free for all the people. In this, CSI has clearly explained that what shall be the scale factor in IS1893 response spectrum analysis definition dialog box. That is this factor. So here it is clearly saying that the spectrum ordinates defined within the various code options, including IS1893, are normalized values in which the spectral accelerations are divided by gravity acceleration, that is SA by G value. The spectrum must be converted to the specific set of units used throughout the model by applying a scale factor as given in the value of gravity acceleration in the current units of your period. Now basically the problem with IS1893 is that the spectrum given is for MC level, that is maximum considered earthquake level. So that is why we are dividing it by the factor of 2 into R, that is response reduction factor into 2. So in the first run, it shall be IG by 2R. After the first run, we shall scale it to the static base shear value. That we will see in the later lectures. So that's what he's saying, that after the first run, check the base shear which develops in the model by static analysis, that is by ELX. And if this value means the RS, response reduction factor value, sorry, the seismic force that is calculated by response spectrum method is less than the code prescribed minimum. Code prescribed minimum is the static base shear value. Then increase the scale factor of the first run such that resultant base shear matches the code specification. So that is why we are putting I into G by 2R value here. So left click on OK, and then again left click on OK. So we have defined response spectrum functions along both the cases. So now we will take these options. After that, we need to define the model case. This is also a very important part. We need to go to define and model cases. Here you will see that by default model eigen is defined. So left click on modify showcase. ETABS always prescribe that we should go for its analysis. So we need to left click on add, and then we need to enter acceleration. So we need to left click on add, and then we need to enter acceleration. Maximum number of modes, I will define it as 3 into number of stories as per my experience and as per beginning analysis. We can later increase the number of modes, but my practice is usually that I multiply the number of floors with 3 to have the preliminary number of modes required. So our number of floors are 26, the 26 into 3 78, or we can take it approximately as 80. So left click on OK option, and then again left click on OK. So now we have defined the model cases also. In this lecture, we will learn how to define P-delta options as per the Indian standards. Unlike American standards, where there are clear guidelines for defining the P-delta load cases and for defining the parameter where code clearly states that whether we need P-delta analysis in our model or not. Indian codes is somewhat silent on the P-delta options. So as per the industrial practice, I will suggest you to go to define P-delta options. After that, there are 3 options, that is none, non-iterative based on mass, and non-iterative based on loads. I will recommend you to go with iterative based on loads. So first of all, we will add DL with scale factor of 1, SIDL with scale factor of 1, and live load with scale factor of 0.5. So by defining this, and when we left click on OK, we will see that in all the load cases, by default, P-delta settings is now iterative and based on loads. Let it be live, let it be SIDL, let it be ELX, let it be wind. So by providing the data here, that is by going to define and P-delta options, when we put the data here, it will automatically be seeded on all the options of the ETABS software. So until now, we have defined the load patterns and load cases. Now we need to define the load combinations. And I have prepared the list for you for your easy reference to define the load combinations. Now there are 2 factors. Some people, what they do is that they simply go to define and load combinations, and they click this option, that is add default design combos. So they select concrete frame design here, and then you need to left click on convert user combinations editable and then left click on OK. But I want to say to you that these load combinations are not always correct and they may lead to error. And plus you manually need to check that whatever the load combinations that ETABS has produced are correct or not. Plus we are doing response spectrum analysis, so there is no case of ELX here. So the better picture is that we need to select all the load combinations and then delete them, because it is always better to manually add the load combinations. So if we talk about the Indian codes, the load combinations are different for different structural elements. That is, for foundation and column strength design, the load combinations are different. And for beam design, the load combinations are different. And for bearing pressure check, that is service load combinations, the load combinations are different. I want to tell you about the nomenclature here. DL means dead load, LL means live load, SIDL means superimposed dead loading, SM snow loading, which is not present in our structure, wind load along X as WLX and wind load along Y as WLY, seismic load along X as ELX and seismic load along Y as ELY. After that, response spectrum load along X as RSX, response spectrum load along Y as RSY, and response spectrum load along Z, that is vertical direction, as RSZ. After that, there is TL and FT, temperature loading and fire tender loading, which are also absent in our structure. So here K1 and K3. K3 is live load reduction factor that we have already applied here. When we had when we had selected design and live load reduction factors, we have already applied K3 here. That is the load reduction, axial load reduction factor for column strength design. So first of all, we will try to work parallelly. So first of all, we will add load combination 101, that is 1.5 DL plus SIDL plus K3 times imposed load plus 1.05 times fire tender. Here K3 is the live load reduction factor. As the number of stories are greater than 10 for the foundation level, so we will select K3 as 0.6. So here we will left click on add new combo. After that, we will always write number here, that is 101. It is important for the order of the load combinations. So why it is important, I will tell you later. So here you will just copy this load combination and here you will select DL, that is dead load 1.5, SIDL 1.5, now imposed load, that is live load. K3 is 0.6 for the foundation level, so 0.6 into 1.5 means 0.9, and after that we don't have any fire tender load, so we can just delete that. So we have now added 1.5 times dead load plus 1.5 times superimposed dead load plus 1.5 into 0.6, that is 0.9 times live load. So we can left click on OK and remove this fire tender here. So left click on OK. Now we have defined our first load combination. Similarly, we will select all the load combinations and define here. For 102, so here what we have done is that we have followed this aspect of the code, that is structure shall be designed for the following set of combination of earthquake effects, that is RSX plus 0.3 times RSZ. So that factor is multiplied by 1.5. It gives us 1.5 times RSX plus 0.45 times RSZ. So left click on OK. Now this load combination and this load combination is almost similar. So what we can do is that we can left click on add copy of combo and name it as 103. And put it as here as minus 0.45. Defining load combinations in ETABS is a very big task. It can take up to even an hour to define all the load combinations. It all depends upon the type of load that we have.
So this is going to take. So this is going to take more time. So if you want, I will send this link. These load combinations is going to take almost like entire video is this load combinations only. This link I will send later on, and I'm just forwarding this video, and we'll go to the
37 plus 37 plus 37, that is 111 load combinations for our structure. And we have to do these type of things. And do remember that after such magnitude of hard work, always left click on OK, never click on cancel. So we left click on OK. So now we have defined 111 load combinations, from which 101 to 137 are for column and foundation strength design, 201 to 237 are for beam strength design, and 301 to 337 are for service load combinations and for bearing pressure check. So when we left click on OK, so now we have accomplished step 12 also. So we can check or highlight the step 12 here. In the next lecture, we will understand how to check the model and how to assign meshing, and how to analyze the model. So in the previous lecture, we have learned how to define the load combinations. So we have defined, we go to define load combinations. So we have defined this 137 types of loads, and then 237 types of loads, 201 to 237 type of loads, and 301 to 337 type of loads. So you can see that how much time consuming work was that to define this much number of load combinations in the ETABS by first of all, clicking on add copy of combo and then renaming it and then applying the name. So there is another alternative of defining the load combinations. So what exactly is that? Before understanding that, we should learn that what exactly is the format of ETABS file. So if we will go to the folder in which this file was saved, you will see that there may be more number of files in your folder depending upon your system, but this is the file that is the proper ETABS file. The suffix of that is .edb. You can see here that we go to list option, and then you can see that the suffix is .edb. After that, there is another file .ebk. So this is the backup file of the ETABS. Whenever this ETB file gets corrupted, you can rename this .ebk as .edb, and then it will open as your ETABS file. And then here is this file $et. So this is the in STAAD we have an editor option in which we can manually enter all the data. $et file is just like the STAAD editor file. To open this file, we need to left click here and then right click and then go to open with option. Here you will see the notepad option. So left click once on notepad and then left click again on OK. So now you can see that this editor file opens in the notepad. So if you will try to understand what exactly is being shown here, on the top you will see that the program information is given, and then controls, that is the units as Newton, mm, and C, that is Celsius. After that, the story height is given, that is the story 26, height 3600, for example story 18, height 3600, and similarly, for example story first, its height is 4 meter. Similarly, after that, the grids are defined in a particular syntax, that is the grid name is given, label is given, direction is given, and the coordinates are given. And after that, whether it is visible, that is yes, and bubble location, that is end or start. After that, diaphragm names are given, that is D1, D2, D3, D4, and type rigid. you should notice that all these are editable. For example, if we want to rename or if we want to delete any diaphragm, you can just select the diaphragm and then left click on delete. But since we don't want to do that, we can just press Ctrl Z on the keyboard, that is undo option. After that, material properties are given in a particular syntax. Rebar definitions, that is we have selected these from diameter 6 mm to diameter 50 mm bar, so it is given like that. After that, frame sections definitions, that is the name of that frame section, material, and after that shape, that is concrete rectangular, and then after that D and B, that is depth and width of the beam. After that, frame sections, concrete sections are given, that is the reinforcement HYSD 500, the cover to the top, that is 35 mm, and cover to the bottom, that is 35 mm. After that, the column sizes, similarly reinforcement is given here, and then as the beams and column syntax is different, here you can see that, and here you can see that this cover is given. After that, confined bar diameter area is given, and the number of confined bars are given. Please note that this option here, whatever data that you are seeing here, this data will not be considered by ETABS for the design, since it will design the reinforcement after our loading analysis. After that, tendon sections are given, slab properties are given, deck properties, wall properties, link properties, panel zone properties, PS names, that is from P1 to P8. And then after that, point coordinates. Here you will see that each and every point coordinates is given in X and Y format. So whatever points we have, this coordinate is given for each one of the points. And after the line connectivities, that is line C1, column this, and for beam it is given like that. And after that, area connectivities, point assign, that is all these points are given as restraint in UX, UI, UZ, RX, RY, RZ. If you will remember, we have assigned all the supports as fixed, so that is why from 1 to 20 all these points are assigned as restraints in all the directions. After that, line assign definition is given, that is this line C1 will be have section will be having property of column having grade this, and auto meshing is selected as yes, and mesh at intersection is also selected as yes. So all these lines are assigned at a particular property, and with a meshing option and meshing at intersection options. Although we won't be able to write all this data here, but some of the options that are given in the ETABS editor file they can be entered manually. Similarly, area assign, and after that, this load pattern definition is given. That is, we have assigned wind load exposure on all these. After that, point objects load are assigned. Frame objects loads are also given here. Area loads are also given here. Analysis option is also given here. Mass source definition is also given. That is dead load 1, live load 0.5, and SIDL 1. And after that, functions, although we are not using here, we are not using any time history function here. After the load cases are given. Here you will see the load combinations options. So this is the option that I am trying to explain here, that we can also enter the data manually here. So before going that, I will explain you all the options of the ETABS editor file. After that, steel design preference, concrete design preference, composite design preference, wall design preference, and concrete slab design reference. And after that, it is given at what time the file was saved and all the data. So right now we will close this option and we will left click on don't save. And what I'm trying to convey here is that we should keep the backup of all this data. Just copy all these files, new folder, original. I will request you to keep the backup of all this data before we will tweak this editor file. So now if we want to change this editor file here, we can right click as copy and then again paste. So if we delete all these load combinations here, and then save this option, we can go to import an ETABS E2K text file. We can left click on editor for import and then open. So when we will go to define and load combinations, here you will see that only one load combination is defined. So whatever changes or whatever we want to do in our ETABS, we can also do that parallel in our .et file. So if we want to add the load combinations here, what we can do here, we can left click here again, so right now this DL plus SIDL plus IL plus 1.05 FT, that is load combination 101, is now defined here. After that, if you want to define load combination 102, what we can do here, we can just select this and click on copy, and after that we paste here. So now we can name it as combo 102. And then we can select this load combination here and then replace it here. So 1.5 time dead load, 1.5 time SIDL load, and after that 1.5 time RSX and 0.3 into 1.5, that is 0.45 time RSZ. So what we need to do here is that we need to change these, and that is load case live and whatever we have written here. We scale factor as 1.5 and scale factor as 0.45, and after that we need to change this load case name here. This after dead and SIDL, here you will see that the load case name is RSX, and after that RSZ. So we save this. Let us check that whether we have defined the load combination correctly or not. So we go to our ETABS, we go to File, Import, ETABS, E2K text file. We left click on editor for import. We go to define and load combinations. So here you can see that the 102 load combinations automatically imported here. So it's all up to you that what option you think is easier to follow. Either you can enter all the load combination data manually through this graphical user interface, through this add copy of combo or add new combo option, or what we can do here is that we can go to our $et file, scroll down to load combinations, and enter all the data manually. So now we have learned how to define the load combinations as per both the methods, that is through the graphical user interface options or through the ETABS editor option. So in step 13, we will define the analysis options. In step 13, the number one option that we need to check is that we need to assign meshing to the frames and shells as per the requirements and model size. So how we can assign meshing to the frames and shells? First of all, we need to go to define. First of all, we need to go to assign frames and frame auto mesh options. So here you can see that by default auto mesh frame objects option is selected. Mesh at intermediate joints is also selected, and mesh at intersections with other frames and area edges is also selected. So we can select all the frames here and then left click on apply. So now this option is automatically assigned to all the frames. After that, we need to go to assign again, assign frames and frame floor meshing options. So here you can see that either we can select it program determine, or either we can select it include selected frame objects in mesh, and either we can select it do not include selected frame objects in mesh. So we can select all the frames here and then we can go for program determined meshing and then left click again on apply. After that, we need to go to assign shell and floor auto mesh options and wall auto mesh options. So we need to go left click here. So here you can see that by default option is selected. In by default option, this is the setting that will be used on all the shell floor object meshing unless another choice is specified on this form. So following are the three categories of shell objects used to determine the default settings, and which one is used depend upon the properties of the shell objects and its orientation. So for horizontal decks and planks, they use the auto quick cut at beams and walls meshing options. For horizontal slabs and layered slabs, they use the automatic rectangular mesh options. And for inclined floors, they use the no meshing options because they are not internally meshed and remains as a single element equivalent in size to the floor objects. So this is up to the user that whether they need to assign this option or not. By doing this, your results will be somewhat refined. I will not say that if you are not doing this, your results will be wrong. But I am saying that if you will do this, your results will be somewhat more correct as compared to when you will not do the meshing. So here you can select by auto cookie cut into structural elements, mesh object into this by this elements, no auto meshing, or for defining rigid diaphragm and mass only. So no vertical load transfer applied to horizontal loads only. So we can go with by default option So whatever it is writing here, it is what is desirable from our end also. So we left click on apply. So by default meshing is now assigned to all the shells. After that we need to go to assign, shell and wall auto mesh options. So here also there are these three options, that is default option, and no meshing for straight walls and auto rectangular meshing for curved walls, mesh objecting to this by this element and auto rectangular mesh. And when we left click on advanced, modify show rectangular mesh settings, here you will see that the maximum mesh size is 1.25. so as you can see that for straight walls no meshing is required, so we can left click on apply and then left click again on OK, because this meshing is a very important parameter. If you will do the meshing wrong, or if you will do the meshing in a wrong manner, or unknowingly you assign meshing to the area which does not really need the meshing, your results can be wrong also, or your model can run into instability, and that instability is, by my experience, is very difficult to remove. So use this option wisely or under your senior supervision, that whether your model needs meshing or not. If yes, how we need to assign that meshing correctly. Our software is self that much intelligent that it can like handle these complicated things by itself also. So we have now assigned meshing to the frames and shells. After that we need to check the model again. As I had said that if we have assigned the meshing in a wrong manner, model will show the instability. So we go to analyze and check model. We will select all the options and then left click again on OK. So here if the software will say that there is some instability or if there is some problem, then we need to resolve that problem before we continue further. Let's hope that there is not any problem here. So model has been checked and no warning messages were generated. If you will do the meshing in an incorrect manner, the software will say that there is a problem in the meshing. So after that we have now checked that the model is our model is now stable. After that, this option here is that go to edit and auto relabel all. See, this is also an option which advanced users do. Why they do it like this? Because it is easier for them to understand or predict by seeing the frame number or by seeing the node number or by seeing the shell number, where exactly that shell or frame or joint is situated in the ETABS model. Because if we will auto relabel all the relabeling will be done in a proper correct sequence or proper correct manner. So we will go to edit and auto relabel all. As it is saying that relabeling cannot be undone, so we don't have any problem with that. So do you want to relabel? Yes. So with this option, all the frames, all the shells, all the joints are auto relabeled. That is, they are assigned a new number as per their sequence. So now we have done this option also, and after that we will check the active degree of freedoms. So here our model is a space structure, is a space structure. So this option might be important when we are designing or when we are analyzing a frame structure or when we are analyzing a truss structure. So here you can go to analyze and set active degrees of freedom. So here you can see that full 3D option is selected, and if we are doing frame analysis, then we can either select XZ plane. So here you can see that UX or UZ is selected and RY is selected, or if we are going for YZ plane, UY and UZ is selected and RX is selected. And if you will select a no Z rotation, here you will see that only RZ is not selected, all the other options are not selected. So our model is a full 3D model, so we will select it full 3D and then left click on OK option. And do remember to save your model after regular intervals. So now, after checking the active degrees of freedom, we need to set load cases to run. What happens is that ETABS gives us a lot of flexibility regarding the load cases that we need to run. For example, if we want to run only seismic load cases, or if we want to run only gravity load cases, then ETABS gives us an option to uncheck or instruct that software not to run that lateral loading or any particular type of loading. For example, if we don't want to run ELX, we need to left click here and then run do not run case. So here you will see that in action it will not run the ELX case. Or if we, for example, if we do not want to run WL minus Y, then left click on run do not run case, and then this load case will not run. But in our case, we need to run all the cases. So we left click on run do not run all. The action will be do not run on all the cases, and then left click again here. So all the load cases will be now run here. After that, you will see that there are various options here. That is show load case tree. After that, it is asking that whether we need to calculate diaphragm center of rigidity. I will suggest you on this type of structure, we should go for calculate diaphragm center of rigidity. And after that, it is asking you that whether we want to run now or not. So now we have set our load cases also. After that, what we need to do here is that we need to check the advanced SAPPHIRE options to manage the sophistication of analysis. If anyone is an experienced user of ETABS, he can easily say here what is exactly the difference between standard solver, advanced solver, and multi-threaded solver. So standard solver is basically good for problem size, good for solution speed, and good for stability checks. If your model is having some kind of instability, then you need to go for standard solver only, because standard solver only has capability to guide you about the instability in your model. After that, it is advanced solver. That is, it is best for problem size and better for solution speed. And after that, multi-threaded solver. That is, it is best for the solution speed and better for problem size. And for structural stability checks, it is good. And after that, analysis process options. That is, it is GUI process is better for small problems and separate process is better for large problems. So we can go ahead with auto, and as our model is a very big model, so we can go ahead with multi-threaded solver. That is, the problem will be solved very fast. So left click on OK option. So now we have also instructed the ETABS that what kind of SAPPHIRE options we need to follow. If you notice that here we are saying that advanced SAPPHIRE options. If you will understand, SAP is also software ETABS. Basically, the thing is that in all the softwares of CSI, the engine that is doing on the analysis is of SAP 2000 software only. So it is like the father of all these softwares. SAP 2000 is the father of, I should say, CSI Bridge. SAP 2000 is the father of ETABS also. So it's like all the heart or all the analysis or all the calculation that is running in the background of the software of the ETABS or CSI Bridge. It is the SAP engine only that is doing all the analysis. So that is why it is called SAPPHIRE options. So after that, we will analyze the model by checking the diaphragm center of rigidity. So we go to analyze and run analysis. After some time, you will see here that it will show us the option of show details. So you need to understand what exactly is software doing here. This is a very important option here. Most of the novice user, most of the new users ignore this option. So what exactly happens is that it is showing the number of joints, number of frames, number of shell. It is showing the RAM memory in my system. And after that it is showing the number of threads, and after that it is going for non-linear static analysis. As we have selected p delta in our analysis, so it is going for non-linear static analysis. Type of geometric non-linearity p delta, and event stepping yes, iteration yes, line search no, and the lumping tolerance and force convergence tolerance is also given here. After that, it is very important that in each step of analysis it should say it as okay. Otherwise, if there is an instability in our model, it will show that the model is unstable or irregular or ill conditioned. I will also show you an example of what exactly it shows when your model is not stable. So we will go here again and then analyze and last analysis run log to understand what exactly ETABS has accomplished. See, this is the most important option. As I was telling you earlier that the number of negative eigenvalues should show it as okay. Otherwise, if your model is unstable or in ill condition, it will show it as your model is ill stable or ill condition, or it will show you what exactly is the problem if you are going ahead with standard solver. So as we have selected the center of rigidity analysis, so it has analyzed. We had used RITS, not eigenvalues, so it is showing the RITS model analysis option. After that, it is doing the response spectrum analysis here, and then after that it is showing the analysis as complete. So now we have completed this step 13. That is, we have assigned meshing, we have checked the model, we have done the auto relabel, we have checked the active degrees of freedom, we have set the load cases to run, we have checked the advanced SAPPHIRE options, and we have analyzed the model with checking the diaphragm centers of rigidity. So in the previous lecture, I was sharing you that what exactly is the error which should not come in our ETABS analysis. So here you can see that the warning is being shown here, that is the structure is unstable or ill conditions. So check the structure carefully for inadequate support conditions, or one or more internal mechanisms, or zero or negative stiffness properties, or extremely large stiffness properties, or buckling due to p delta or geometric nonlinearity, or frequency shift onto natural frequency. So to obtain further information, use the standard solver, or run an eigenanalysis using auto frequency shifting with additional mass if needed, and investigate the mode shapes. So in my experience, if your model is having some instability, it is better either to consult your seniors, or you can send me that model and I can also look into that model to see that what exactly is the instability that you're getting and what exactly is the reason behind that. Most of the times it do happens that either your support conditions are wrong, second thing, your beams and slabs are not properly connected, or your slab is half in the air or half connected with the structure, or you have assigned the units wrong to some properties, or there can be any other depending on your credibility or depending on your experience with the ETABS. Most of the times, or what I have seen with my juniors, what they usually do is that they ignore those options, they give me that model, and then I run that analysis, and then I see that there is an instability in the model. So all the work basically goes down the drain if you have not, if your model is unstable. So right now we have checked that our model is not running into any kind of instability, and we have also checked the analysis log and the result warnings, and we don't have any warnings in our model. And after that, we can check the global forces and approximately cross check the result. And the most important thing that we need to see here is that we need to check the deformed shape under first mode and second mode, and desirable shape, or sometimes recommended shape or sometimes required shape under first and second mode is linear translation only. So if someone is inexperienced or if someone is using the software and structural dynamics for the first time, he might not understand what exactly is this linear translation under first mode and second mode. So what we need to check here is that we need to go to display and deformed shape. After that we need to left click on mode here, and the mode number is now being shown here as 1, and then we left click on apply. Basically this is the fundamental mode of our structure, and in first mode the time period is 4.271 seconds, and here is an option for animation. So left click here, start animation. The software will process the animation frames. So here you can see that your model is going translationally along its primary axis. So the best thing about this is that the model is translational only. This building is not getting twisted. After that we need to check the second mode also. So we can left click on add new window here. And now with this window is selected, we left click is applied to, that is mode number 2. And here you will see that to our surprise the building has twisted. So left click on start animation, select this window by clicking anywhere, and then left click again on start animation. So our time period from the fundamental mode, that is 4.271, has decreased to 3.954 here, and the shape, that is in first mode it is translational, that is it is desirable shape, but in second mode it is pure torsional mode or pure rotational mode. So this thing is not desirable at all. And after that we need to check the third mode also. So left clicking on add new window. So by selecting this window we can left click on mode 3 and then left click again on apply. So the time period from mode 2 of 3.954 has gone to 3.814 seconds, and then we left click again on start animation. So the behavior that should have been in the mode 2 is now coming in the mode 3, that is somewhat translational rotational mode is coming in the mode 3 instead of mode 2. That is in mode 2 the mode is torsional, and in the mode 3 it is somewhat linear translational. So this is the screen that is showing all the first 3 mode shapes, and you need to understand it very carefully what exactly I am trying to say here. That is first mode linear translational, very good. We had always desired this type of behavior. Second mode pure torsional, very bad. We do not ever want this behavior in our structure. And in third mode the building is going for linear translational mode. So the mode that should have been in the mode 2 is coming in the mode 3. See, people always say, or like when most of the juniors ask in our office, or like most of the inexperienced engineers ask, why we are not recommending anyone to go for torsional mode in the first and second mode. I'm again asking, I'm again repeating what exactly I'm trying to say here. Why no one recommends that in this mode and in this mode, that is fundamental mode, mode 1, and second mode, that is mode 2, there should not be any torsional behavior? The reason is that if there is torsional behavior in the mode 1 and mode 2, all the columns will behave in an isolated manner to the earthquakes. redefine our structural arrangement in a manner that our fundamental mode, that is mode 1 and mode 2, should be translational only, so that all the columns will behave in a group when the earthquake force will come in a particular direction. So how we can make this building from this second mode as torsional mode to translational mode, that we will see. Before that, we need to close this windows. So now we have checked the deformed shape under first mode and second mode, and now we can see that our second mode is torsion. So we need to go to step 7, that is we need to rearrange our structural geometry.